Thanks to our early entrepreneurs in the robot field, ABB has meant a great deal for the development and growth of the industrial robots worldwide. For example, thanks to ABB, arc welding is one of the largest applications worldwide today. There are so many reasons for us to be proud of ABB's robot history. I am proud, and I would like you to feel the same. So let's look backwards and see how it all began. I'm standing here beside the first electrical robot in the world sold to the industry in 1974. One of the most important persons behind this innovative bestseller is standing right here beside me. That person will guide us back to the early days, and he's the father of the electrical robot, Mr. Björn Weichbrodt. Welcome, Björn.
Thank you, Jan.
Björn, can you tell us how it all began? What was it like when you entered the world of robotics?
Well, for me that was in 1971, and looking back to the start, the first robot, the first commercial robot in the world was developed by Joe Engelberger at Automation in the United States, late 1950s. And that was an hydraulic machine, rather big. It was intended for machine applications. I believe the first task was to work with a grinding machine. It was a rather large unit. It could be programmed point-to-point, accuracy 1 to 10 millimeters. And I believe at that time when I started there were something like 3,000 robots in the world that we knew about.
So this was the situation of the industrial robot when ABB, formerly ASEA, entered the scene. So Björn, what was the main reason behind ASEA's involvement?
Well, I think Kurt Nicolin, who was our president at that time in the 60s and 70s, he saw the potential of robotics as a future potential business. He had himself a professional background as a production engineer. I think he made a general decision to see if we could not get the company into that robot development as a business.
Were there any other reasons?
Well, yes, I think you have to realize that at that time, now in the 60s, numerical control tools, machine tools, electronically driven, that had become a generally available product. And that was causing our manufacturing plants to become very efficient in each singular machine operation. But when you tied a number of the machine tools together, the transportation in between took time and the whole process became quite long. And there an industrial robot could make a big improvement. You could speed up production. That was what we were thinking about, speed up production by machine tools. And what we had, the Automation robot, could do that for us. But if you look at an hydraulic robot, it is very big, it is rather clumsy, it is noisy, it requires a lot of electric power, and it's not a very clean device. So it has a lot of disadvantages that really are based in the hydraulic drives. And we realized that, and we didn't really like those robots at all, but they were the ones that could do the job in our manufacturing plant for us.
Did ASEA at the time have the right conditions to develop its own robot?
Yes, I think so, very much so. And you must understand that ASEA was already a major company in developing electrical systems. So we had very good resources to develop electrical systems generally, already making numerical controls for machine tools. We had a very good capacity in mechanical design, mechanical parts of a robot. We had also a very good experience in software development. And the fourth part of it, which is just as important, is that we were also really good at running machine shops. And this meant we had the production technology. This is knowledge of how should you use robots. So yes, I think we had a very good position for entering the market.
Björn, How and when did you fit into the picture?
It started in late in 1971, and at that time I wasn't actually in ASEA at all. I was working with General Electric in the United States, where I have moved about 6-7 years earlier. I was in charge of a development group that developed automation, and very interested in robotics, but the initiative really went the way that I visited with ASEA to see what was going on. I was interested in Sweden. We started to talk about robotics, and the result was that Kurt Nicolin, he offered me a job to develop a new robot system, and I accepted. That's how I got in.
Could you describe how this project was set up and when exactly this happened?
In 1972, in April, we made a formal decision to start development, the robot program. At that time, in April 72, I had formed a vision of that we needed a project team that would be a complete team, if you will, not only have the development phase of mechanical, electrical, software systems, but also something about the production technology, and also think about what would the applications be and how should we market it. Kurt Nicolin said yes to that. We got a yes, and we got in permission to get 20 people together that we picked out from various areas of the company, representing all these areas. And we had a very strong goal to develop a first robot physically present to demonstrate from April in 72 until February in 1973. Because at that time, Michael Wallenberg, our very big chairman of the company, had decided that that would be a good time to demonstrate the robot for share owners and some of the public. So that was the starting point.
I'm very interested to hear more about your design principles, how you choose between the different concepts. So let's discuss the manipulator. All robots at that time were of hydraulic or pneumatic types. So how come that you didn't choose one of the existing technologies?
The designs that were available at that time were hydraulics and some were pneumatic, with all the limitations that we have talked about already. And in addition to that, there would be good reason to try electrical systems of DC drive type or stepping motor type. And if you really, as I did, started to think about where is it that we could expect the future to develop best, I felt that if you're going to run a project to develop a new system, a new main system for the ASEA company, we're a company that is a big expert in electrical systems, some computer systems involved in that too, electrical power systems. That company is for sure going to develop that technology strongly in the future. And hydraulics was a little bit more of a sidetrack, I felt. So as we continued the development and we continued to try different areas, we did it with hydraulic systems, with pneumatic systems, with electrical systems, but all the time I had in my mind that I hope it's going to be possible to end it up with an electrical system.
What were the main alternatives to create the motion?
We had basically two types that could be functionally working well. Our first thought was a stepping motor. If you know, a stepping motor is a motor that takes a step for each pulse that it gets, but it does not have a feedback system, so you don't really know absolutely sure that the robot is at its right position. And then you have to have a lot of extra margin in terms of the power in the motor. So we didn't really like that after we had tested it. Instead, we selected a drive with DC motor, actually a DC motor with a resolver, because we felt that that's going to give us a quiet solution. ASEA is a good company as far as making DC motors. We could get very high accuracy, we could get low noise level, a lot of advantages that would serve the purpose of having a robot not just for materials handling but also for process applications. So we decided on the DC drive.